Hello guys, this is learning CUBS back, and today it's about functions. My first the maths lesson. So without going for any explanation, let's go for our explanations. This is a simple function. We put x through a mystery machine to add 2 for it, and we get x plus 2. So there are some technical names for these mystery things. This x is our input. So the input has got the technical name domain. This mystery box, this mystery machine is got the name function machine. This x plus 2, our output is called as range. Our input is named as domain. When we talk or when we say what's the input of a function machine, you must may be able to answer which is domain, range, function machine. Like that you must be able to answer. X is domain, input, add 2 is the function, function machine is this, and range is our output. Our first subtopic, identifying functions. There are two ways. By mapping diagrams is one and graphs is the second one. There are two ways of identifying functions. First way is by mapping diagrams, second way is by graphs. So now we have got our first way of identifying functions, mapping diagrams. So if I take 1, 2, 3 in one box, and I will name that box as our domain, and I will draw another box 4, 5, 6, and that will be our range. What is range? Output. So I am saying this first digit, number 1 will become number 4, 2 will become 5, and 3 will become 6. You can see it from arrows. And these type of mapping diagrams, if one digit goes only for 1, these type of mapping diagrams are given the name one-to-one mapping. This is one. There are 3 types of mapping diagrams, and this is the first type, one-to-one mapping. I'm going to do now. And in this, I'm saying 1 will become 4, and 2 as well will become 4, and 3 will be 6. In this, you just have to consider only this part. In this, you can see 1 have become 4 and 2 also have become 4. So in this type of mapping diagrams, many, 2 or more is given the name many, right? So many has gone to 1. So this type of mapping diagrams are given the name many to one mapping. Many to one mapping. Many has gone to 1. This is the second type of mapping diagrams. This is also a functionable, acceptable function. This is the third and the last type. In this, I'm saying 1 will be 4, and again 1 will be 5 also, and 3 will be 6. In this, you have to consider the opposite. You have to consider these parts only. 1 will be 4 and 1 will be again 5 2. This cannot be happen. Now if we take a orange and if we try to make juice, we won't get apple juice for free. So it's same like this. So this is not a function. It's not acceptable. But these type of function mapping diagrams also has got a name. This type of mapping diagrams are got one to many. One to many mapping. This is the name that this type of mapping diagrams are got. So now we know what are the 3 types of mapping diagrams. We have completed one way of identify functions. First way is mapping diagrams. In mapping diagrams can be split into 3 parts: one-to-one mapping, many-to-one mapping, and one-to-many mapping. So in this, only one to many mapping is not a function. Other both are functions. Our second subtopic, function notation. This topic is function notation. This topic, if you understand this topic, you can go forward in the forward in this lesson. So now you know, if I put 2 to a function machine which has the rule to double it, I will get it 4. It's useful. So instead of this word double, I can put a letter. A letter we don't know, but that we know what it means, because here it's double, and if we put f, I'm putting f to this function machine instead of double, but f means also double. So if I insert 5 to this f function machine, I will get 10. So for this we can write, now we know it's doubling, no? 5 into 2 is 10, so double. So I'll write a function notation. This is called a function notation. This is where you start everything. F5 will be equal to 10. This means f from f function machine, if we insert 5, we get our range as 10. In the same way, for this domain and the range, we can put mystery letters also. If I put x for this, through this f function machine, I'll get 2x, doubled. Then for this I will write like this. We can also write like this also, but this is another way. This is one way of writing, and this is another way of writing the function notation. This part means these brackets. This equal sign means this arrow. So it's totally the same, but it's another way of showing the function notation. So from this function notation only we are going to do a few, the other subtopics. I'm going to give you an example. I'm saying if hx is equal to 3x minus 2, they're saying to find h2. So in this, I will take this. If I must write h2 equals 3x minus 2, and instead of this x, I should substitute this number 2, because here they said hx and here it's h2. So instead of this x, I must substitute this 2. So let's go on. hx equals 3 into 2, because it's multiplication here. So 3 into 2 minus 2. So what's our answer? Then hx, h2 is how much then? 3 into 2, 6. 6 minus 2, it's 4. So h2 is 4. It has been doubled here also. So now we'll go for the second one, hy. Again we must write hy equals 3x minus 2. Then instead of this x, we must substitute this y. So I'm going to do it. hy equals 3 into y minus 2. Then I will get my answer. hy will be 3y minus 2. So this is the answer. So hope you all have understood this function notation example. Have you ever seen a square root having a negative number? No, right? So, 0 we have not seen. So for this we must find what must be excluded from the domain. So now we must, if we take this down here, I'll take this down. We are without the square root, 2 minus x only. I'll take 2 minus x will be equal to 0. It will be equal to 0. Then to make this positive, I'll take this x this side and I will write 2 equals to x. 2 is equal to x. Then I will substitute this 2 here. Then I will get 2 minus 2, I will get 0. So this is the second example. Have you ever seen a square root with a negative form? No, right? So we must find whether this is a negative number, which will be, then if we find a value for x, it must be negative. Then only we can say that that must be excluded from this domain. So what is the domain here? It's x. The range is 2 minus x. And now I will write, I'll take this 2 minus x here. Then I'll write 2 minus x is smaller than 0. Because we need to get a minus value. If we calculate this, it must be lower. Then I'll take this x this side to make this x positive. Then it will be 2 is smaller to x. Then x must be a value bigger than 2. So if I take a value bigger than 2, if we take 3, then I'll take this down right here and I'll write 2 minus x, and our value is, we took 3, then 2 minus 3, we will get minus 1. So minus 1, no negative square root numbers will be there existing in mathematics. So because we got this full, only we got a negative number. So this must be excluded. We must write 2 is smaller than x must be excluded from the domain. This is our third subtopic, composite functions. Composite functions are functions when one function is followed by another function. Now you can see here, this is a composite function notation. In this gfx, there are two functions here. G is one function, f is one function, and x is the only domain here. We must find the range. Now if I explain it with example, it will be very easy for you all. If they say find gfx, this is one function. This is a composite function because there are two. If find gfx if f equals x squared and gx equals 1 down 3 squared, 3x. That means they are saying, they are given two values for us and they are saying to find what is this. For that, we must take, because we must take, first of all, we must take the function which is near the domain. In this gfx, what is near the domain? F. F is near the domain, so we take fx first. Fx is equal to how much? It's x squared. Concentrate on this very carefully because this is very important. This is the place where everybody get confused. Then we have got fx as x squared. Now we are done with fx. Now we have to go for this g function. Now I take gx. I take gx equals 1 down 3x. Understood? So here I have got the domain as this. Still the domain is like this only, because now for example, if I put x squared, okay, if I put x through f, I will get, again I must go through g and only get my range. So when it go for the f and come out, it will be, if we put x into f and it will be x squared. Then this x squared will go through g, not x. X squared only will go through g because it has already passed this. So g for this, then this x will be substituted from this x squared. Because we are not finding x no longer, because x is no longer valid. Because x squared has been formed because after x goes through this f function. So here it must be x squared. Again you must write gx squared equals 1 down. Here instead of x we must substitute this x squared. Then it will be 3x squared. Because we substituted this x instead of this x. We substituted x squared instead of this x. We get x squared. Then our final answer, we must write our final answer like this. They said to find gfx, no? Now we have find gfx. This is the gfx. We must write g f x equals to, what's the answer? 1 down 3x squared. Understood? This is our composite function range. So we know our functions, we know our domain, we know our range also, so we are complete with our function. So this is known as composite functions. When one function is followed by another function, it's known as composite function. Then it will be 3x squared. Because we substituted this x instead of this x. We substituted x squared instead of this x, we get x squared. Then our final answer, you must write our final answer like this. They said to find g f x, no? Now we have find g f x, this is the g f x. You must write g f x equals to, what's the answer? 1 down 3x squared. Understood? This is our composite function range. So we know our functions, we know our domain, we know our range also, so we are complete with our function. So this is known as composite functions. When one function is followed by another function, it's known as composite. Last subtopic that we are going to talk today, inverse functions. There are some steps, this is the reverse one. If we take from domain to range, it's the opposite of it. If they will give the range for us, we must find the domain. Now earlier they gave the domain and we must find the range. Now in this, they will give the range and we must find the domain. There are some steps to be followed in order to get the domain of the range. The first step is make an equation y equals function. Remember these steps, because in this way only you must do the inverse function, or else you will not get marks. Step 1, make an equation y equals function. In this way you must make the equation. Step 2, change values from y to x and x to y. Values which are y you must change to x, and values which are x you must turn to y. That's the second step. Third step, subject y. You know how to subject y, like y equals ax, like that. Subject y. Step 4, write your answer in inverse function notation. For example, f minus 1x. Like earlier we wrote fx, no? This was our earlier notation. But now we must write like this, because we are finding the inverse of it. Like if you take sine, it must be the inverse sign. So like that, in this fx, f inverse fx, and so on, what you must be ready. So this is an example in order for you all to understand about inverse functions. Now they are saying find inverse function of fx equals x squared plus 3. Now we must find the domain of this. They have given us the range, we must find the domain. So what's our first step in the steps which I gave you? We must make this a y equals function. So we must write y equals x squared plus 3. So we have made the y equals function. Now first step done. Second step, what's our second step? We must change the y values to x and x values to y. So let's do it. Here what are the y values? It's here. So we must make it to x. Then we must write x equal. Then this x must be y. Then y, and the squared must be there itself, plus 3. What's our third step? We must subject y. So I'll take this 3 here to the other side. Then it will be x minus 3 equals y squared. So we must subject y, not y squared, remember. So we must cut off this power. So I take this, if I take the square power of the side, I'll get square root for this side. Then square root of x minus 3 will give you all y. So we have subject y also. Now first step we are done. We have made y equals function. Second step also done. We have changed y values to x and x values to y. Third one also we are done now. We have subjected y. What's the fourth step? We must write in our inverse function notation. So this is our answer. No? So this is our domain. So we must write f minus 1 x equals square root of x minus 3. So this is our inverse function. They have said find inverse function of fx equals x squared plus 3. So in that I have made y equals function I have made first step. Second step is to change y values to x and x values to y. I have done that also here. I have changed. And the third step is to subject y. So I have subjected, I have taken this 3 this side and I have taken the square this side and I have done it. Last step is we must write it in the inverse function. So f minus 1 x equals square root of x minus 3.